What would happen if you fell into the center of the Milky Way? The Sun is the core upon which Earth depends for survival, but to the Milky Way, it is merely one among hundreds of millions of stars. Even the solar system, nearly impossible for humans to traverse, is but a remote corner located on the Orion Arm, 26,000 light-years away from the center of the Milky Way. Humanity's only impression of the Milky Way is the milky white band of light stretching across the entire night sky, resembling a quietly flowing river of stars, traversing the expanse of the night. The brightest and most concentrated direction of this band points towards Sagittarius, which marks the true center of the Milky Way. No one knew just how bustling the center was until NASA's Spitzer infrared telescope pierced through cosmic dust and dense gas clouds in 2019, offering the first glimpse of its true appearance. It is an extremely crowded place, where hundreds of thousands of stars are densely packed together, orbiting the supermassive black hole Sagittarius A, at speeds nearly 3% the speed of light. This black hole, with a mass equivalent to 4 million suns, occasionally emits ray and infrared flares as it devours nearby celestial bodies. So the question arises, if humans were to truly journey here and stand in a region so dense with stars, extreme in gravity and prone to sudden bursts of radiation, what would happen? Would we be instantly swallowed by the black hole, or would we be gradually eliminated by the environment, long before we could even get close? Let's now venture into the heart of the Milky Way and explore what falling into its center would truly entail. Starting from Earth, the Moon is quickly left behind, and the orbits of the planets stretch out in our field of vision. The Sun, once the star illuminating the entire world, gradually shrinks into a mere bright spot in the night sky. Once we completely leave the solar system, we are greeted by ghostly bands of light and gas, the very inspiration for ancient myths and legends. As we race through the sea of stars, every tiny point of light we pass is a star like the Sun, with at least one planet orbiting it on average. Some of these planets even resemble Earth and lie within the habitable zone. However, whether life exists on them remains a mystery. Scientists have estimated that in the quiet expanse of the Milky Way, there are at least 4,000 Earth-like planets, but whether any of them harbor life remains unknown. Thousands of light years from home, Earth becomes a distant memory, and the stars ahead grow exceptionally dense. Here the distances between stars are not measured in light years but in light weeks, hundreds of times the distance from the Sun to Pluto. If you were to stand on one of these planets, the night sky would forever be bright, illuminated by countless suns in an eternal day. At the very center of this stellar stage, a group of stars orbits an invisible object at insane speeds, completing a single revolution in just a few decades. In contrast, our Sun takes over 200 million years to complete one orbit around the Milky Way. At the end of this 26,000 light-year journey lies Sagittarius at the true core of the Milky Way, with a mass equivalent to 4 million suns, compressed into a space smaller than Mercury's orbit. The dazzling white light we see is not the black hole itself, but its accretion disk, a glowing vortex of gas and dust, accelerated and heated before plunging into eternal darkness, spewing lethal radiation jets spanning thousands of light years. All paths leading to a black hole are one-way streets with no return. If you fall into a black hole, you won't die instantly. The laws of physics present you with three distinct outcomes. The first, fate. According to Einstein's theory of general relativity, if the black hole is large enough, you won't feel anything unusual as you cross the event horizon. It's like sailing across water, unaware of the invisible boundary. The only sensation is tidal forces. Your feet experience stronger gravitational pull than your head, slowly stretching your body into a stream of particles, inevitably leading to spaghettification, before plunging deeper toward the central singularity. The second, fate. Stemming from quantum field theory, physicists proposed the famous firewall hypothesis to resolve the black hole information paradox. According to this, the event horizon is not calm, but filled with high-energy Hawking radiation particles. Any matter touching this firewall would be instantly vaporized. From this perspective, you'd be burned to ashes at the boundary, never entering the black hole intact. The third, fate. To reconcile the contradictions between the first two theories, physicists proposed the revolutionary holographic principle. This suggests that all your information never truly enters the black hole, but is instead encoded on the two-dimensional surface of the event horizon, much like information stored on a credit card chip. The frozen image seen by external observers and your falling experience are merely projections of the same holographic information across different dimensions. These three explanations cannot all be true simultaneously, yet each is backed by serious physics. This leads some to ponder. Could there be a fourth possibility? What if a black hole is not the end, but merely an entrance? Could information in the distant future emerge from the other side, perhaps from a white hole? It's important to clarify that a white hole is not an escape hatch. It doesn't mean you could walk out alive, but rather that information might not be trapped forever. Instead, it could re-enter the universe, in a form we no longer recognize, like a drop of water disappearing into the ocean, only to re-emerge as clouds or rain, continuing to exist in another form.